Good morning and welcome to the webinar hosted by myself, Daniel, and brought to you by Baker Paints. This is Factories 101, Factory Utilities 101. This is part one of our Factories webinar. We're going to be doing part two as well. And it also touches on some of the factory utilities or factory tools that we used in our last webinar. Okay, so let's get started. The agenda pretty straightforward. We've got a bit of a summary that we're going to discuss around factory tools. A recap from our last webinar, which looked at some of the best practices when using factory utilities. We'll jump into factory utilities itself. So more or less showing you how to create these factory utility tools that can be your assets that can be used inside of either AutoCAD or Inventor. Now, AutoCAD, it's the flavors of AutoCAD. It could be AutoCAD Architecture or AutoCAD Mechanical, and that will be translated into Inventor as we move along. Again, we look at publishing of assets. So we will publish an asset. We're looking to see how the feel of an asset in a 3D environment, especially when you're working with Inventor. Tools like iLogic and how it helps and makes life easier when working with assets, and then we look at the workflows between AutoCAD and Inventor. And following that, we've got questions and a close off. So without further ado, let's start off with the summary. So again, Autodesk has great workflows, okay, in the factory environment between applications like Process Analysis 360, AutoCAD Inventor, Navisworks, right? So in this webinar, what we're going to do is we're going to look at more or less exploring some of these best practices. But we're going to focus and pay a lot of attention to how we set up these factory assets, because without the factory assets, we can't really place any intelligent equipment inside of our factory and move them around. We can also look at exploring options with iLogic, again using iLogic with the factory tools, and we'll see what the possibilities are of that. So just a quick brief recap on from our last session. So our last session we looked at the factory tools, and this is available to us in the product design and manufacturing collection. It incorporates with AutoCAD, with Inventor, as well as the factory utilities, as well as AutoCAD Architecture or AutoCAD Mechanical, and using the Process 360 tool. So as you can see, what's highlighted on the board there, these are tools that work hand in hand and form this workflow. Navisworks is also part of that workflow for visualizations and clash detections, but we'll look at that in our next webinar. So an image of what a digital factory would look like using the factory tools inside of the product design and manufacturing collection. And as you can see, a rendering, this comes straight out directly from Navisworks. You can see it can get quite detailed, which is really, really great if we need to create a factory layout or also optimize and look at a process flow of how efficient the factory is. Just looking at the Industry 4.0, and I thought I might just add this in because as we know, Industry 4.0 is the next, this is the current or the next industrial revolution. And what this means is that in these areas of automation, there's aspects that need to be considered when working or when considering Industry 4.0. So this combines a lot of technologies, become well known, and it's combined in steps. So firstly, product design and process. Okay, we got to understand the process of it. Following that is monitoring and control, and this is the use of active sensors and becoming intelligent. And then manufacturing operations. So having the flexibility, but also having precision in controlling it, and using different types of flexibility, having the additive manufacturing, different manufacturing techniques. And then moving on to that is, of course, service integration, maintenance of that factory, as well as work organization. But in our focus for today with factory utilities, this is where we can make the best use of having the factory tools. So in the design process, as well as in the process of the factory. So you can see it touches into the Industry 4.0 that we're trying to achieve. And what about digitizing of production lines? So if we look at the production lines of it, as such, you see it's great for two types of project processes. So a greenfield projects, so which is new projects that we're going to design, and you can see the workflow in that. The layout's designed, it's optimized, and it moves back and forth between the 2D and 3D environment. Okay, that's for our greenfield projects. If we look at the brownfield projects that we do, so these are projects that's existing, and we're going to add and do some additions to it. So as you can see on the left hand side there's a scanner which will scan the project or scan the environment. If we look at the right hand side of the corner there of the screen, you'll see that that is a recap file that's come in, which allows us to actually place in our equipment to see where clashes are or if there's any obstructions on the way, so we don't set up our factory with any hazards or any obstructions that needs to be reworked later on. This is a really, really, really nice way of actually working our brownfield projects, only because we can see if there's any clashes or any obstructions beforehand. So following that, just a touch on this. This is the process analysis tool. On the left-hand side, you can see a transportation analysis directly from Inventor. Now we're going to touch on that a bit later on today, as well as the Process 360 tool that is available with the factory utilities, which gives us a detailed, in-depth scope of the factory processes that we're simulating. Now, next, if we take this a step further into an animation environment or a visualization environment, you can see the workflow that it adopts, and these are platforms and waves that can be used using using factory tools to actually have great virtual reality visualizations. So again, looking at factory layouts in here, you'll find that Inventor drawings, okay, you can use AutoCAD wireframe, they come in. It's possible to include the AutoCAD architecture building. Okay, section views for the building are not supported in parallel, so that's something to consider. It needs to be the solid itself or the wireframe of it. If we look at what this looks like more in depth, we'll be able to see that the architecture building comes in, as you can see in there. This is in Inventor. Sorry, AutoCAD architecture. We could come in, create a solid mesh of that, and also see that we've got the building that's coming in. Now this is great because what it does allow us to, if we switch over to Inventor and we pull in the asset, so this could be our architecture model that we brought in. We bring it in as the multi-body part, so they're all individual. And as it loads, notice that it's a solid body. Now this is great because we can actually bring in the intelligence from AutoCAD architecture across, and we don't have to restart this or restart the design. This is a good way to kickstart our design to actually get the design going and move from that workflow. So what it does is allows us to create that workflow between AutoCAD and Inventor. However, moving along from here, we're gonna demonstrate starting off firstly with the asset, publishing the asset, and then how that asset is being used across in the environment. Okay, if you synchronize back, you find that inside of Inventor itself, the solid body is there. That could be suppressed or switched off in here or deleted if possible. And you will see that you only left with the factory layout or the factory floor space, which can be translated back into AutoCAD, or it could have additions going on to it. Now, if we overlay the factory that we've just well, the building that we just edited inside of Inventor and brought in from AutoCAD, you'll see that if it's placed in here, we can actually have it go over. And these are all Inventor tools, so Inventor and AutoCAD tools, so it's not necessarily something very different to what we used to. It follows the same workflow that we know and use daily with Inventor. Okay, we can pick that up in the browser, have a look at the solid bodies, turn a couple of them off. And we're left with just the top of the building that's coming off, and we just switch the visibility off so we can see what's going on inside. Now, this is just a recap from our last session that we've covered. So I thought it would be great just to show you this before we move on. So we're going to jump into the demo, and in this demonstration, what we're going to do is we're going to start off looking at the factory utilities itself. So publishing a factory asset, how that works, how do we publish it, and from there moving along. So to start, we're going to start up and got a model that's in here, which is being created. It's a 3D solid model, and what we're going to do is we're going to publish this asset coming across. Now, firstly, we've got to define our landing space, and notice that on the left-hand side there, you see that there's key parameters that can be added in. We could bring these parameters in here, right? So firstly, we've got to define the floor, where it's going to land on, and then a connector. Now, if we look at the connectors that's coming in, that's at one point there, and that's at the other point there on the model itself. Now, these connectors will for you to place them in, and then following the connectors, you can see with the parameters itself what we can have in. Now, defining connectors itself, now in here we're going to place the connector, one connector in there, and the next connector is placed in there. Now, what this does allow us to do, it allows us to actually bring in the connectors that we're going to place, and how does our asset connect to each other when we're assembling them. Now, if we look at the connectors that we're placing in here, we could always go back and modify the connectors like that and define our landing spaces. So where we're going to define our X, Y, and Z coordinates for when we go in and assemble them. Now, you might notice that if this is done correctly the first time around, when you place your asset in, they connect quite easily. So we want to have the Z-axis face upward and the X-axis face away. And of course, the Y-axis faces towards us. We can look at asset variance. Now, with the asset variance, you'll find that in here, you could have a variation of assets. You can create a new asset variant in there. Let's remove that. And you could bring in the parameters that comes in as well. If you don't want to see it, you just can minimize that and OK it, and it will close. The great thing about that is you can have multiple variants of the same asset, and you could go in and change a lot of them. If we go into the properties, we can change the name in here of the author, and this information is very similar to our iProperties. Well, it is the iProperties, and this can be pulled across and used downstream in our design. We can add a description to that, add in a parameter that would come in, and also set up the processes from here. Now, this is a very handy tool, because what it does is allows us to define a lot of our processes inside of the properties that the asset that we create or publish. Now, layers can be considered. Any customizations you can add to it, any customized properties, and if you're happy with that, you can OK it. Now, what's great about this is once we've got that, we can publish the asset. You might find that I've got there's the model in there, key parameters in here on the left-hand side that can be added in two connectors over each other. So it gives me a warning, as you can see there, which is great because it's got the very same functions and tools that we're used to working with on the left-hand side of the model browser tree, which gives us any warnings if there is any issues. So In this example, as you've seen, I've had two connectors over each other. It's not going to accept that. We have to have a single connector connecting to each other, well, connecting where it connects. Otherwise, we're duplicating our connectors, which is not great. Following on, just creating the asset itself, we can go in and open up a pre-created model which has a sorry, I'm repeating myself here. We could create an asset which has some iLogic built into it, and what this does is it would actually allow us to see what the asset looks like now using iLogic. Now this is an Inventor iLogic part. You can see it's got a landing surface, so it's being created as an asset in here. I've got all the key parameters coming in. If I go into iLogic, into the form, you'll find that we can control our assets using these iLogic forms. Now they are quite nice and quite great because what we can do is we can have them, our assets that's being controlled by our iLogic, be in a specific position that we need, and we can move those constraints that's been set up for that. Now notice that what we can do is we can modify this. Now if this is going to be something that needs to move along, we can always go back a bit later and modify that. Let's have a look at the code that's been there. The first code is just blocked out just to let you know what's going on, and this tells us the rotation of certain aspects of this asset, which is really cool because in theory what we can do is we can go in and modify the position of it and have that placed in our factory environment. What's good about this is once we publish our asset to the factory catalog or the factory asset, we publish the asset to it. We can have different variants that come up, and we can modify the variant while it's in the factory. So, for instance, if it's going to be different size, perhaps, or length, we can have that modify and adjust. If we look at again, sorry, I think I've done the same. And again, if we look at the workflow that's adopted, we can see that it starts off in AutoCAD, and from AutoCAD we move on to creating our floor plan, our layout, and then publishing that to Inventor or synchronizing to Inventor to give us a full 3D visualization representation of our layout. So let's open up to a typical example here. We'll open up a drawing. This could be an existing drawing that we're working off or something that we create from scratch. Gonna xref something in. Xref another drawing in. Let's remove that one and just reload a new one. Catch DWG. Okay, what's important here is the way it comes in. So make sure that it's an attachment and the scales and locations where it's going is available to us. Now we can open up this bounding box here, the reference, the clipping board, and this is more or less what we're going to do. We're going to lay out our factory tools. Going to come in, and on the left hand side you'll find that we've got the asset browser. Now this is some customized tools that I've got, as well as some standard tools that's here. It comes with quite a bit of factory assets preloaded for you, so there's no need to go and create them. However, if you need to create them, you can go and create your own as well. So I'm just going to remove some of these machines here just to show you how they snap and fit together. So we're going to drop in the first component in here. And as you can see, it's just placing and dragging to the angles that we need. And of course, using standard AutoCAD functions, like rotate, for instance, will allow us to actually rotate this in the direction that we require. Now, I'm going to bring this down here, zoom it in a bit. It's 0, that's fine. Okay, that's it. That's what we need. And we're going to add a little bit more to convey it back. Okay, and if we go back in here now, we can see that in this environment that we have, this is our 2D environment. We can do our placing of we can place our equipment in the 2D environment, and what this allows us to do allows us to set up the layout that we're going to work with. Following this, we're going to actually go in and create a synchronization of this into the 3D environment, so we can see how this will affect or how it'll work. So it's been placed in. We've got of the components coming in. We synchronize with Inventor. It'll prompt us to actually save this, and as soon as we click OK, it synchronizes with Inventor and it creates that floor plan for us, having all of the equipment that we placed in coming in the 3D environment. As you can see, the machines that we've placed in there, the people that we placed in the floor plan will follow it, and of course our 2 machines at the end, with our conveyor that's there, which is very cool, because now we can actually have great visualization. Our molding machines that you can see coming in there, the conveyor that's there, and it allows us to actually have a good visualization of what's going on. However, whatever we have in here is still very intelligent, because if we look at it, it's got all of the inputs or the detail that we've added in from Inventor itself when we publish that item. Okay, if we can have a closer look at that. Okay, there's something that came in that can be easily removed, as you can see. So if something that comes in which is not supposed to be there, we could easily remove that. Now what we're going to do is we're going to add in some more equipment directly from Inventor. So in this case, we're doing it from Inventor and not from AutoCAD. As we place it in, we can rotate it or align it to the area that we need to. Click OK, done. And remember the connectors that we set up earlier on. Now you'll see them in a bit of action. So you'll see that they snap to where they need to be. And once these connectors snap to each other, it becomes quite easy to actually work with them, because they're snapping into place. We're not going and constraining them, we're just adding them into it. If we look at the asset browser or the factory properties, this allows us to actually set up and change different types or modify our asset. Now, this is very simple. This is where iLogic becomes really, really powerful. In this example, you've seen it was initially an inside asset. Now we've changed it to an outside. The asset that sits inside of it, we can change that and update it. As soon as we click on the update button, you find that it will update or will change. And let's do some modifications to that. We'll change that to inside. Click update, and notice that the arm is gone inside. Now, if we move it out, we could change the different variants. So as we set up variants, you'll find that it will update and change and move along. Now, in here, once you update it, you find that it has changed. Now, this is quite a change, quite dramatic. We can undo that change if we don't want it, or undo multiple changes as well. Okay. We could also remove it or replace it. It's optional as we go along. We don't have to keep it the way it is. It's just to show you that it's really, really nice if you preset all of your variants, and inside Inventor, when you publish it, you make sure you publish it with those variants. And when you get into the 3D environment, it's easy to modify them and do those changes. Okay, we're going to add in another component in here. Okay, as you can see, it's snapping in as the last change. So, so it will remember your preference from the last time. If you go outside again, and we hit OK and update, it should give us a bit of a change. There we go. So it's adjusted itself to the component that it was snapped to, which is really great, because it gives us a very nice way of working with it. It gives us a lot of options and flexibility when we're working with this in 3D environment. Okay, as you can see that, it's in our factory floor. These floors can be resized to any position that you want it to be. If we synchronize it back to AutoCAD, we've got to hit save. It's synchronizing back to AutoCAD. And when we open up AutoCAD, we're actually able to see what it looks like in a 2D environment from the top view. So it's our 2D layout, right? Yes, we want to open up in AutoCAD. And when we bring it into AutoCAD, you can see that it has come in here. Our equipment that we placed in last has been placed further than our area. That's not a problem. We can easily move that. Again, using AutoCAD drag functions or even AutoCAD tools like a move, and we can bring that in to the center point and position them in. Now, this is really great, having the back and forth interoperability, because what it does allow us to do, it does allow us to actually move our components out if need be, and if it needs to change or needs the alignment or placement of it needs to be modified, it's easy for us to do it in a 2D environment. Now, moving along, we're going to go back into bringing in the main model and our external reference that we've got here. It may look as double for now, but ignore that. It's perhaps just a visualization of it itself from the screen. So what we're going to do here, we're going to go in and create that process layout that we've had initially put in. Now, if we do it, we can do it either using process tool, or we can use the transportation or material flow inside of AutoCAD mechanical. Now, I'm going to refresh the XREF. Let's close that. Open up the material flow browser. As you've got it there, we can look at stations. Now, certain stations have been defined as CNC stations, the user stations. If we go in and create a routing, we can place our routing from station 1, which is our area, our racking system, then to our CNC machines. Station 2. Okay, so once that's done, we can go in and have a look at our routing itself, and you can see that in station 1 where the routing is going, which is really, really cool because it tells us the way it's being routed. Now, if we append that, and we could close that routing up. So what we're looking at is we're looking at routing from those stations. If we go in and click on transportation, it will tell us the amount of energy and resource that it's using from all the way from routing 1 to routing 2. To routing 3 itself. So it moves along, right? We can rename it, as you can see here. That can be renamed. Doesn't need to be the same name. We can change it to the processes that we're more familiar with, and of course, we can modify our routing to suit the specific type of energy and cost that's involved. It's a nice just overview of the times. And again, if any of these stations are moved out, you would see a dramatic dynamic change in the cost or even the efficiency of that route that we've created. Okay, so if we jump back in here, our routing is done. Sorry, I think we're on the same again. So moving that along, from there, what we can do is, let's have a look at our routing that we've done. So the routing's done, transportation. We can see that we can move it along. We can check our machine efficiencies here. If this is all set up, kilowatt per hour, we're happy with that. We're going to sync it across to Inventor. Now, again, as you sync it across, you've got to save it, and you've got to allow the synchronization. So AutoCAD will prompt you to actually say, yes, we are going to sync. Do you want to save the last version of that? And let's move it across. So inside of Inventor, we're going to bring in the complete model. So it will take a little bit longer than the first time, but nothing more than 5 minutes, depending on your machine. It's coming in, it's coming across. As you can see, it's not long at all. It's actually quite quick. And once this completes, we'll have the full visualization of our factory floor in as much detail as possible. That's 80% there. And here we go. Now you can see that was actually not too long for quite a large setup or large assembly that we have. And what we can do is we can actually look at the complete workflow of what's going on in here. Now, if we orbit around here, we can see our factory itself. If we highlight our cursor over some of the equipment, you can see that it gives us a slight description of what it is, as you see in there, which is quite cool. It looks quite great. If we take this into a Navisworks environment, it'll give us very nice renders, animations, workflows. You can see there's some of the components clashing, so it's going into each other. That would need to be modified, and that will happen in the 2D environment, or it could happen inside here. We just got to reposition it, but it's a lot easier and a lot better if we use a workflow where we modify it in the 2D environment. Now, as you can see in here, the syncing to Navisworks from here is pretty straightforward. Same process, synchronized with Navisworks, and it takes us in where we can do our clash detections, our timeliner simulations, as well as some walkthroughs and fly-throughs inside here, which is really, really cool. That we'll cover in the next aspect of the webinar. In our next webinar, we'll cover having the animation of that, and of course, looking at attaching recap to it. We could attach it, looking at our bill of materials. You'll see that in here there's quite a bit of detailed bill of materials that comes through. So in this way, let's enable the bill of materials in here. In this way, you'll find that you can export it or import in from here, export it to file formats, and let's do a quick export here. And you can export it as Excel as well, okay, if need be. So bill of materials could come in here pretty nicely, where we go in and have a look at our data that we currently have and export that out. Okay, so that brings us to the end of it. It's just a brief overview of creating an asset using incorporating iLogic into it, having the workflow from AutoCAD to Inventor, and it allows us to actually do it quite seamlessly, as you've seen. So, in conclusion, it's a very simple and easy way to create factory layouts from AutoCAD mechanical or architecture and bring that across to Inventor. Okay, we can also optimize the factory layout. As you've seen, we can do analysis or a time study of stations, and what the efficiency of that is, what if there's a cost linked to it, energy cost, if we move stuff across, how that affects it. Also create 2D and 3D versions of the layout. So you've seen initially we had a 2D version, we had in some XREFs, we could be working with different team members, adding in their data into our model, synchronizing that to Inventor to have that 3D layout created for us. And it's also a seamless workflow and integration between AutoCAD and Inventor. In the next webinar series, or the next webinar that we'll be covering, part 2, we'll be looking at doing a bit more in-depth, taking the same design, bringing that into Navisworks, and also adding in recap files and seeing how that would integrate with each other. So please, for the next one, please, if you found this really interesting and you found this informative, please join in for the next webinar, and we'll carry on the same workflow from here. Before we close off, I'm going to leave the floor open for some questions. Please, you can use the message box to type a question in or raise your hand. Alternatively, you can get in contact with me with my details on the screen, either by email or a telephone call. So we'll leave the line open for a little while. So please go ahead and ask your questions. No questions as yet. Everyone happy? Please, if there's any questions after the webinar, you're more than welcome to get hold of me. Alternatively, just send me an email and we can have a discussion about that. I give it a couple of minutes more. If there's anything else, please raise your hand and we can address the question. Or alternatively, type it in the message box and we'll be able to pick the question up from there. Okay, no questions. Okay, guys, thank you very, very much for attending. I look forward to seeing you to the next webinar. Please be on the lookout for the dates for the next webinar. That will be emailed to you. And I look forward to seeing you there. Have a great weekend and have a good day. Thank you very much.